What's up, guys? Welcome back to Organic Chemistry Simplified. Today we're going to be going through resonance structures. So I'm going to cut to the chase here, save you guys a bunch of time. Let's get right into it. Resonance structure is another representation of the same molecule. That's pretty much it. So when the question asks you to draw a resonance structure and they give you a compound, there's two steps you need to go through. The first one is find your source of electrons, okay? So there's three sources of electrons. The first is a negative charge, the second is a double bond, and the third is a lone pair. And once you find your source of electrons, all you have to do is draw curved arrows to show the movement of electrons and to get to your resonance structure. So why don't you guys try this question out, see if you can draw a resonance structure of this one. Alright, so hopefully you tried this one out. So first step, what do we do? Let's go back up. Find source of electrons. So negative charge, double bond, and lone pair. In this case, we do have a negative charge, so that's where we're going to start. So let's draw an arrow, let's bring it down, let's create a double bond there. And because we can't break the octet of this carbon, let's move this double bond over. And that should give us our answer here. And we don't have any formal charges here because we moved our lone pair away from the oxygen. And so we created a double bond there, we neutralized that, and then we also neutralized this plus charge by moving the double bond over. So this is our answer. Now I drew this figure here to explain what's called a pi system, and this is pretty much what makes resonance structures possible. So basically everything highlighted here in blue is the pi system of this example. And as you can see, the electrons can move freely across this whole system. And so a good way to identify a pi system is look for double bonds in consecutive order. So for example, something like this, right? That's a pi system because we could move these over. Another is to look for a negative or a positive charge next to double bonds. So something like this, right? We had a negative charge, we pushed down the lone pair to create a double bond, and we pushed this double bond over. So just look for like consecutive charges or double bonds, and that's where you're going to see a pi system. Okay, so now this is how you know if you've messed up in doing a resonance structure. So either your overall formal charge on both structures is different, or your curved arrows are not showing the movement of electrons. So I want you guys to take a look at this one right here and tell me, where is the error? Alright, so if you said it's because the overall formal charge on both structures is different, then you'd be correct. So if you look here, we have one plus charge and one minus charge. But in the product, we have one plus charge. So the overall on the left is neutral, but the overall on the right is +1. So that's impossible. So we know we definitely messed up here. And so the correct answer does not have the plus charge there. In this case, where do you guys think the error is? All right, in this case, it is the second bullet here. Curved arrows are not showing the movement of electrons. So please remember that curved arrows always show the movement of electrons. So you should never start from a plus charge. In this case, we started from a plus charge, so that's not going to work. The real way to represent this is we're starting here. We're moving that double bond over, and this plus charge ends up on the right. So I have one practice problem for you guys to try out. Pause the video and see if you can draw a resonance structure of this molecule. Alright, so step 1, find your source of electrons. In this case, we have a minus charge here, so that's going to be our source. So let's start by bringing this down, creating a double bond. We know we can't break the octet here on this carbon, so we're going to move this over. We also don't want to break the octet of that carbon, so we move that over. And then we also don't want to break the octet of this carbon, right? So we have to move that up as well. And this should give us our resonance structure here. Okay, so this becomes a double bond. This becomes a double bond here. This is single. And then we have a minus charge on this oxygen. Right? So hopefully that was helpful. If you guys found this video useful, please be sure to check out the description below, where I have a link to my website where there's more free content.